Okay, so this would be a good example of a tank that you may be asked to build, whether it be for water or fuel or oils. So this is the bottom. What size is this plate? 10 by 10. You can call that our top. What's that dimension, you guys remember? 8 by 8. Okay. And then the sides, remember the dimensions on those, all four? 7 by 8. Okay. 7 tall, 8 wide. So before you shear, you can grab, say this is the front edge of the blade on the shear, you can grab that front edge and measure how far out the part's sticking or how far in the part is sticking to the edge. Okay, verify before you make a junk cut, and then check it for square when you're done. It does come off the shear with a burr on it. Okay, these are deburring tools. This is more for like an internal circular shape, but it'll take that burr off, so no more is that kind of sharp edge protruding from that shear. You can use deburring tools, you can use file. This one's got the built-in handle, which they're pretty handy. Okay. This one's pretty slick. We can adjust the spacing in the teeth based off our material thickness. And it deburrs 2 edges at a time. Okay. So it's a hot rolled low carbon steel, pretty soft and malleable. But it does have that mill scale on it, right? We are going to use 6011 electrode, 3/32, because anytime we got oxidation, we might have the potential for some porosity or some discontinuities. And we go to pressure test this, what could happen? Maybe we have a little bit of a spot that doesn't test out. Let's go over to the pipe threader real quick, and I'll show you how to thread a pipe, and then we'll come back. Okay, when you get your box built, we'll test it with this. We'll put just a slight amount of air in your box and then spray it with some soapy water. So we'll check it with air, and we don't got to use much. We just got get a little bit of positive air that's sealed off inside your box that wants to escape. We spray some soapy water on there, it makes some bubbles, we can find the leaks. So that will fit on top of that nipple that's sticking out of the box. This is a 2-inch female fitting. Okay. So now we have to make the male end, the nipple end, to go in the tank. Remember how long that has to be? 4 inches. Okay. This is the first one I did, and if we look at the threads, in the bottom section of them are starting to tear off. This one, they're nice and clean and smooth. I only changed one thing, speed. Okay. There's speed adjustment right here. So if you guys want to come around and look, we got reverse, off, and forward. And this does have a foot control. So right now it's going in reverse. You also have speed controls here. So I just walk up, thread this first one, and it comes out nice and rough looking. Well, what's wrong? Well, it's on high speed. So we look down here at this chart. Recommended high speed is up to 1.25 inch pipe. Okay, we go up to 2-inch pipe, we got to be down at 46 RPM. So all I did is change the speed and then rethread it, and then the threads came out just fine. So make sure you're verifying the speed on that. This threader will cut, thread, it'll bevel. If we throw the other teeth in there, it'll actually put a bevel on your pipe to weld, and then it'll deburr as well. And it also has an auto tightening chuck, so as soon as you go in forward, it's got these jaws that centrifugally just lock onto the pipe. So right now you can see that it's loose. As soon as we hit forward, the pipe's locked on there. We can kind of get it to loosen again, right? If we do that, but if we just hit reverse, then they'll change their direction and then loosen off the pipe. Okay, so if we want to cut, don't force it, kind of let the jaws do the cutting for you. And I'd wear rubber gloves if it was me. Or it is me, I'm wearing them. If I were you. Okay. Okay, so that's what it'll look like when you cut it. There's a big nasty burr on the inside, so we definitely wouldn't want a product running through that. Put it back and forward. So this kind of puts it out of the way, locks it out of position. That'll lock it in position so we can use it. Don't check it with your finger, right? Don't reach in there and see if you got it all, because it'll slice you up. Okay. There's a little bit of a burr on the outside edge, just a little bit. And that's something we could clean up if we had to with a file or something. We don't want anything hanging, even if it was nice and clean, we don't want anything hanging on the inside that could become part of a product later on. So you got to think about that. Okay, so now it's time to thread. Really what we're shooting for here is kind of counting our turns. So count how many times we can turn this fitting on here. If we can get about 2.5, that'd be ideal. You definitely don't want anything less than 2 for sure, but this is a tapered thread. Okay, so if you look at it really close, it has an angle to it. And that's what tightens up the thread as you turn a fitting. Okay, so initially here on this taper, the threads are a smaller diameter than they are back here. Okay, so the taper is actually what does all the tightening for you. It can either be too big of a diameter here where you can't get enough turns to get some strength in the thread or get it to seal, or you can have too many turns to where that taper is too small and it never does tighten on the threads. This is pretty cool. We can go from 1 inch up to 2 inch pipe. Okay, so we need this to be 4 inches long. So let's thread it first before we cut it. Okay, this little cam lever here, it engages and disengages the teeth. There's this line on this handle, this little cam as it comes across, has to line up, has to line up with the diameter of pipe that you want to. So we're getting only 2 turns, so we actually want to make that taper a little bit smaller so we can get more of a turn on it. So we can actually adjust that line a little bit towards a smaller diameter of pipe and then do another run on it and see if that's a little bit closer to what we want to get 2.5 turns. So this is disengaged when the handle's back and it says open. And this is with the teeth engaged and it says closed. You'll have to do it manually to get it going, and then it'll just draw itself through. Once it starts making threads, it'll actually start threading itself. You don't even got to touch it. The next time you touch it is when all of the teeth have cut. So you can see the back side of this tooth there. When all of the threads have cut, that's when you'll disengage the jaws. The worst thing you can do is stop on the pedal. You want to disengage the teeth before you stop on the pedal. The worst thing you can do is stop on the pedal. You want to disengage the teeth before you stop on the pedal. So I'll show you what it looks like when you don't disengage the teeth. Ooh, see how it just came to a halt? Okay, not good. I don't think you can get something to thread on there. Okay, so let's start over. Disengage the teeth, or engage the teeth. We're in forward. Okay. So last time I let off of the pedal, right? This time I'm going to let off on the teeth. And kind of slowly. Let off on the teeth. And kind of slowly. A nice gradual release on it. Again, and you see the teeth came out nice and clean. All right, so now we got our threads on there. We can check them. Okay, so there it starts. There we got 1 turn, 2, okay, and we got a little more out of it. If we went to 3, maybe we'd back that line a little bit more towards the bigger side. You can deburr it. And then we can cut it to length. We need 4 inches. Okay, this tooth is where your cut's going to happen, so you can just measure right off that tooth. Don't think you're going to stop anything on this machine by grabbing it. So let the machine come to a stop. So now we have this internal portion which has a burr on it. No, we don't have enough room. So this internal portion here on this inside, you're going to have to deburr that yourself. We don't want the jaws to lock on your threads, is what I'm trying to get to. I think that's it. So now we can take this back. Okay, so how are these fitting together? Corner to corner, right? We're not going to overlap this way any more than we're going to overlap that way. Okay, so the secret to welding this thin material is actually getting it to touch. If you can get it to touch, you're halfway there, because as soon as the arc gets close, it'll actually create a fusion between the two parts. Okay, if we have a gap in there, now we got to use the electrode to fill that gap. So a better option than that deburr tool in that area would be grinder. Just keeping in mind that if you do grind, if we could explode the view of this edge, if that's the, our material looking at it from the side, we still want a nice square edge there, right? Because when we go to corner, we want a nice square edge coming from the other direction where we can lay our fillet weld. Does that make sense? Sides. Okay, so what would the next step be? We can even weld that fitting into the top. We could put the hole in the top, put the fitting in it. Or we could actually use, we wouldn't do it on this table, but if we had a big chunk of steel that we could use as a chill plate, we could clamp it or tack it down to that chill plate and weld our fitting in if that was an option. And that heavy plate would help pull a lot of the heat out of the, like I said, there might be 28 different ways to do this tank. And there may not be one perfect way to do it. So let's lay out where this fitting goes, so you don't got to lay it out later. How do we find the center of this? Put an X on there. There you go. That's the simple way. That's going to be pretty darn close to middle. So now we can lose that mark and we know where our hole goes, regardless of when we put it in there. So now our base plate, you said our bottom plate, lay that out. So here's that little tricky part. What's the size of this again? 10 by 10. What's the size of this? 8 by 8. How thick is 14 gauge? Up to 0.74, maybe 0.75. So how would we lay out this bottom plate? This is 10 by 10. This is 8 by 8. If we need to put lines on this plate to guide us to fit it up correctly, where do we put the lines? 1 inch in, right? So that's 10, that's 8. How is it getting fit up? How are we putting this thing together? We're going to do this, right? So if you want to be able to see your lines on the outside, you'd have to minus a material thickness to see that line on the outside. If you want to see your line on the inside, then you're just going to go that 1 inch. So let's do both just for the fun of it. This is chalk, so it might disappear. Most of your Combination squares has a little baby scribe that's pretty much useless. If you really want to keep your line, then we could go this route, put a few center punches in it. Right, so no matter how much that line gets smudged, we'll still be able to see that spot. So you can do that too. All right. Okay, so the next step would be, I got everything laid out. I'm ready to drill that. I'm ready to put it together essentially. So I'm going to drill my hole after it's put together. So now I need to know where my settings need to be. For 6011, 3/32, 40 to 85, okay? These are just two sheet metal edges coming together. So we might not want to use 65. Maybe we do, maybe we don't. But how do we know? I do a little bit of a test. So that sounds pretty hot to me for 14 gauge. Let's try 55, I don't know. You say we go down to 40? So we still have some room to go down if this doesn't work. Okay, so we have to weld an outside fillet and an inside fillet. Is the amperage going to be the same for both? So I would assume, I would think, you know, maybe this would require less amperage than the inside, but I don't know. So we got to give it a little bit of a test. So we're at 55 amps on DC. We'll just tack together a corner to corner first. Cover. And let's do us an inside fillet too. Covered. With this electrode, we can actually go vertical down. 7018, we need to go up because of all the slag involved, right? 6010, 7010, we can go downhill. There's not enough to get ahead of us and to cause some issues. So we could practice a vertical, we could practice a horizontal. Cover. So you can see it's penetrating all the way through. So 55 would work. I think a lower amperage might work better. Give you buy you a little bit of time. So this is whip and pause sped up like really fast. Okay, we still get some penetration, but we got a little bit more control about what's happening. We don't feel like the world's falling apart at any moment. Okay, you don't want to be riding that edge like all the time, right? You still want to feel like you have control. So I feel like I have better control. There's still nothing wrong with doing a little bit of practice and kind of brushing up, because this is a different technique. It's pretty quick. I mean, things are happening fairly fast. You don't got much time to sit around and wait. And do a little bit of checking first. So here's my top, right? There's my sides. Make sure you don't start tacking the sides like that. There's still nothing wrong with, this is my top, this is my base, and that's up. Do that to all of them. Didn't take long, but it's going to take a long time if you got to cut it apart. I've had to cut a tank apart. Why did I have to cut a tank apart? I have to cut a tank apart. It fit up so well. I mean, it's one of those ones where like nothing could go wrong. I left something in there.
I left something in there.
Dead blow hammer and a tape measure. When you're ready to weld it and all of a sudden you hear a clunk, like where's my tape measure? So I'll just show you a freehand way. See how I can walk these walls around side to side? So I can overlap it that way, I can overlap it that way. Okay, I didn't tack all the way at the top. I want to leave that area for later. Typically our leaks, if we do have leaks, they're going to be on a stop and start, say on this pipe where we stopped and started, they're going to be on these corners, the outside corners or on the inside corners. So stops and starts on our corners, that's where the most common areas are to have a leak. So I'm going to leave that corner open so I can really burn into it later. Your squareness is actually kind of limited to the pieces you have now. So as long as you're doing the correct fit up, that corner to corner, as long as your pieces are square, your part should come out fairly square. Cover. I'm going to clean up my tacks before I go any further. Okay, you want to do that now because if you go to tack it on this base, it's going to be harder to do that, right? So you might as well. And the key behind a good tack is it needs to be strong enough to hold the part, but not any bigger, essentially. You want to be able to weld into and away from that tack and still get complete fusion all along that path. I'm going to turn this amperage up a little bit to tack. One of these parts was a little bit longer than the other, right there. If you have parts that are a little bit different, see how that one, I don't know if you can see it, but this one's a little taller than that, just how it came off the shear. It's not bad enough to where we got to throw the part away, but I would rather make that my top. This top, we can actually, later on when we go to fit that, if we have a little bit of a gap, we can use our hammer to bring that material together. So I'd rather have the difference between the two be at the top than at the base. Now I'm tempted to tack in the corner, but I really don't think I should because that's where we have those leaks. So I'd rather burn into that nice and hot. So I'm going to try to keep my tacks away from those corners. Cover. Okay, a little bit of a tip if you're able to. You can actually see how good your tacks were and how they weren't. That one was kind of crappy. I can hardly see the heat from that one. Okay, most of these other ones are pretty good. If you're able to get to this section, you can actually tap on these tacks. That's just going to get it that much tighter, right? Just a little bit better fit. So the tighter we can get those parts to begin with, the closer they're going to come to each other to be able to fuse together when we bring the arc to them. And here's, now that we're doing corner to corner, here's where you're going to have a little bit of an issue. This is going to want to fall right in. So we could do something like that. Well, we'll get something holding it in so it doesn't fall. Cover. Okay, not always does this stay flat if you're not careful. If this material starts caving in a little bit and you tack it, you're not going to have a corner to corner anymore. So here I'm starting to get a little bit under that top plate, so I'm going to leave that for a second. I'm going to tack where I got a good fit and come back to it. Okay, you'll notice I got a gap on that. I'd rather have gaps than have it be under, because the gaps we can bring together pretty easy. If you tap on it while that tack's still warm, you can bring your parts together. This stuff at low amperage, sometimes it just wants to stick. You got to be a little patient with it. Okay, so here's the one that was underneath a little bit. We can pry that out. And then you want to do like the Santa's little workshop stuff on this. Just keep tapping until you get everything as close as possible to touching. So the same thing you did to the outside tacks, you're going to want to do the inside ones as well. You don't want to have to weld over those big old ugly things and expect it to seal the tank up for you. Okay. So what's that called? Feathering, feathered tack. So we did the same thing on the groove weld, remember? Where we ended or where we had a tack, we're going to taper the ends of that off so we can get good fusion into it. Okay. The trick to that, especially on something like this, is though, I'm coming down to the surface of the material, but I'm not thinning it out. You don't want to make this 14 gauge all of a sudden 18 gauge thickness on the edge, right? You want it to still be 14 gauge thick. Okay, so now we could put this pipe in. Nothing's in it. Okay, we can do this with a hole saw. We could, you're going to want to clamp stuff down. This is called the arbor. This is called the hole saw. Okay, it's a saw in a circular pattern, so it makes a hole. Most people just put the hole saw on the arbor and go to town. The problem with that is, all too often this piloting bit breaks. And all too often that the pilot drill will go all the way through, and it'll happen so fast that it'll catch and create some tension in there and snap that pilot bit. So I like to drill my pilot hole before I put the hole saw on. See, we weren't just that, boom, that'll bust it every time. Okay, so on this we could put oil, we could put wax, we could use water. If nothing else, we want to keep it cool. But this thing will catch and fly around and bust your ribs and smack your face and before you can even let go of the trigger, so just be careful. Bye. If you're lucky, that drop will stay on your drill bit. Yeah. If you're not lucky, it falls in and then you got to fish it out. Yay. But typically we'd want to remove that burr. Most pipe has a coating on it, so you want to grind that coating away where the weld goes. How far is that pipe sticking out? 3 inches? If this was a bigger pipe, or more substantial pipe, we could just put a pipe wrap around it, which is, put that on there, keep it from falling through. Okay. You put a line on there, so that's a good reference, but don't assume just because your line's on there as correct as you think it is doesn't mean that's where it needs to go. So we'll make sure we verify it being square to the world once we get a tack on it. So now our pipe got thicker. So we want to make sure we burn it in pretty good. So now you can do the little pool stick thing if you want to. Be a little bit more accurate. Yeah, that thing burned in nice. I like that. Crazy how out of square some of these come. Okay, we're going to feather these just the same as we feathered everything else. And when you have different metal thicknesses coming together, typically you'll want to concentrate, usually you're going to want to concentrate more of the heat to the thicker side. Now it's time to weld. Took a long time, right? Just to do that. Now the welding take that long. Welding don't take that long. As long as you did the fit up right. As long as you did the fit up right.
As long as you did the fit up right.
Now we can actually cheat a little bit and do our welds that are more susceptible to blowing through or require less amperage, however you want to look at it, first. And then the heat created from those welds we can use to create maybe a better fusion on our inside fillets. So I'm going to weld the outside corners first. So now I'm going to start welding. Well, you need to keep the arc below the weld pool. So if you don't keep that electrode ahead, you're going to be welding on top of your weld. And then there goes all of your penetration. All right, so we call that riding the puddle. We can actually do that when we want to get less burn through. We can ride the puddle a little bit. But usually we want that to lead out ahead at the very edge of the weld pool, so now it's burning into it's welding to what we want it to weld to instead of welding to our weld, right? We don't want that. So that's why we're going fast, is to trying to keep the weld pool up here and our arc below it. Okay, so just like we feathered our tacks, we're going to feather our stops. Okay, this one will have a tendency to burn in a little bit more. So if you were fighting these corners amperage wise, you might want to turn it down a little bit, because now vertical down, you know, we don't get as much penetration as we would have horizontal. So that's something to think about. If you were kind of right, now you can leave it. But if you were kind of right on the edge, like, well, I'm really fighting this, the amperage is a little too high, you might want to turn it down for that horizontal one. So what's more critical on this, the look of this weld or the fact that this tank seals? The look of this weld would mean I'm going to stand here and make sure my bead looks really pretty, right? This tank sealing, I'm going to think of it as this. So I'm going to really watch that joint and make sure that arc is following that joint as well as I can. So here I have a drag angle, here I have a drag angle, right? They're both the same. This one's a little more awkward because I'm welding towards myself, but I can really see that arc dive into the joint way better than I can see it going this way, right? Got a little bit of a gap there. If you do blow a hole, don't stop. Just keep going. You can come back and fix the hole. So the worst thing you can do is stop, and now you got a big old hole to fix right where you stop. If you make a hole, just keep going. No big deal. Hole. So for something this critical, I know we don't like to waste electrodes, but think of this as your tacking stash. Okay, I'm not going to start a new weld and then have to stop halfway on something like this. So I know we burn to the numbers, but typically what we do is that's what we use to tack on the next thing. We don't throw it away, we just use it for another purpose. It's actually easier to tack with shorter electrodes because they're not as floppy. You can put them where you want them to go. There's a hole. And we blew a hole right in the beginning. Touch her up. Let's try 65 amps on the pipe. Don't start and stop on your tack. Burn in and out of that one, so start where you don't have a tack. Or just stick it. You might have a leak right there on your stop, so you might want to get a thin cut in there and feather that out. Now if you look close how I'm doing it, I'm trying to carry more of the heat on the pipe and bring it down to the sheet metal. Now we just clean up and test it. For the purpose we're using it for, if you want to weld it and then quench it and test it, you can do that. But it's definitely not something that's a recommended practice. This is just Teflon-based pipe dope. How many? 5 pounds. A lot. A lot. That's 5 psi. Let's see if we can get this thing to pop. Yo, stand back. You can start seeing these sides expanding now. See it? Yeah. And that's 7, 8, 9 psi. That's not much. Sometimes they're small. If it's a really, really minute, like almost porosity type of leak, it'll start developing this little trail. It's kind of cool. Of the same size little bubbles, but typically they're going to look more like that. So, that's it. it.